What's going on, my peeps? It's good to talk to you. I'm just so excited to be back. Let's turn on the light so you can actually see my face. It's my pretty face that actually really needs a haircut. We've got Shayla here who doesn't want to be seen on camera. It's good to talk to you folks. It's good to have you folks around. I've missed you guys over the summer, over the winter break. How was it? How was your winter break? Shout out to that chair she's sitting in. Yeah, shout it out.
Yeah, it's a beautiful chair.
All right. So you know what you should do is you have to teach me how to be like a YouTuber. You know, like, do I have to say like LMAO, AO, or you know, R Rolf a little bit more or something like that? Do I have to be like that? Or something like that? Because I want to be cool. I want to be cool like you guys. You guys are like 13. And I'm like 3 times your age. So, oh, excuse me. Well, that's even cooler. 14. All right. Anyway. Oh, LMAO isn't very appropriate. You're right. It isn't. That's right. I don't think about these things. So I don't even know. So I apologize. Yes, there is none of that allowed. And I'm not even going to tell you what it means because it's not allowed in our class. Anyway, let's get started on what we're talking about today. Look, I have my course up, and the plan is up there too. Look, see, there's the plan. Here, let's turn editing off so you see more like what you guys usually see. So look, I have the plan, and it's up, and it's good, and I have like the first 2 weeks up there already. And guess what? I want everyone to applaud for me. I even have all the drop boxes up for the next 2 weeks.
Oh,
Snap.
Yeah,
there's you applauding. Thank you. Yeah. So we're gonna I have a section called scheduling. I have a section called content and assignments. And I have a section called notes. And if you go and click on this schedule, like today we're in the week of January 6th through January 10th. You can click on it. It will actually take you to the plan, and not only to the plan, but it will take you to the week in the plan that you need to go to. Come on, that's kind of cool, right? There we go. Round of applause for Mr. Dalday. So I have the stuff up already, and I'm going to kind of just go through with you. I'm going to spend 2 minutes talking about what we're coming up against this quarter, okay? So here's what this quarter is going to look like. This week we're going to cover astronomy. And next week we're going to cover more astronomy. We're going to spend 2 weeks on astronomy, because astronomy is a very, very cool topic. I don't know, are you guys excited about astronomy?
Yes.
All right, cool. Now the week after that, there is, so this is week 3. There's a few things in the hiccups, in the standards that I didn't cover, like the biology and evolution and all of that kind of stuff. I didn't get to that, because that's usually covered in 7th grade, but I'm going to recap a lot of it for you. Okay, so this would be week 3 around there. It's a 3-day week? No, well, it's a 4-day week, I suppose, because there's no school on the Monday of Martin Luther King Day.
Wait, so next week?
No, this is today's the first week. This is the first week. So on the 3rd week, there's Martin Luther King Day on Monday. On the 4th week, and I'm getting all this information from I write a little sentence as to what I plan on doing. So we're going to kind of wrap things up, and then for the last half of this class, we're actually going to start studying for the HSA. Because you guys are going to take the HSA. Yes, you're going to take the HSA again, but the first time you took it, you only took it in math and English. This time, it's my domicile. We're taking it in science. This is the real deal. So, this is the science test. So I want you guys to do well on the science test, because it just makes me look good. No, anyway. Nothing can make me look good. Nothing will make me look better than I look anyway. All right. The week after that, we're going to do a little bit more of HSA studying. I was thinking maybe we can have a face-to-face class where we all come in and we just do like a big study time from like 10 to 2 or something like that. Maybe we can all pitch in a few bucks and pick up a few pizzas from Costco,
God.
kind of hang out, do like a cram session to study.
What day?
I'm thinking around the 31st, the end of February, because like your HSA test is actually going to be on the 11th of February. Which, if it's on, why would I do that on the 31st of February? This must have been January 31st. I was saying, why would I do January 31st or February 31st as the review session if February 11th is the thing? I don't even know what I'm talking about. I probably have to change that up a little bit. I bet you I was thinking that not the 31st, let's say Friday 2-7. You know what I mean? And then for those of you online, I apologize, and those of you who are in Virginia right now, I apologize, but this is not like this will be virtual pizza for you. Although it would be cool to have like pizza with you guys.
They could order pizza.
They could order pizza and we could all eat it together. The HSA is that week, and then the next week after that, after you're done with the HSA, I figured that you guys have been science geeked out, right? You guys I've been teaching you science hardcore, boom, 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 boom. I'm gonna break it. Let's take a break from super science and let's go into something kind of fun, and let's program arcade games. So we're gonna build arcade games,
Oh my God.
build like Pong, and we're actually program things. Like we're gonna design a calculator. We're gonna draw pictures on a computer programming, and we're gonna learn Python programming. We're gonna build Pac-Man. Yes, we could build Pac-Man if you want. It will be awesome. We can build 3D Pac-Man. And I'm going to teach you how to do that.
Let's build Skyrim. Yes.
What is Skyrim?
It's an amazing game.
Oh, okay. So for the last couple of weeks, we're gonna start talking about how to program arcade games. So that's kind of what I'm going to do. And the reason why I'm setting you up for that is because next quarter I'm going to plan on teaching you the physics that you're going to need to know to kill the classes next year. I'm going to teach you guys the advanced science, but I'm going to teach it to you in the context of programming arcade games. So it's kind of a switch to switch in your brain, but it's a fun tool that you're going to use. Are we cool?
Yes.
All right, I've got 7 minutes to cover something else, and then I want to switch to talking about my lecture. I probably won't get through all of it because I'm going to do a cliffhanger. I'm the master of those. But hey, I've got 2 weeks to talk about astronomy, so let's get into this thing. Cool? So that's the plan, and that's kind of the basic idea of what it is. I get to change this plan and add the assignments to it. For the most part, I have the first and the second week built out, and then stuff. Didn't I say I was playing Minecraft? No, I am not a Minecraft player yet. I'm sorry. I want to talk to you about your final exam from last quarter. I'm just going to go over the answers with you guys real quick, just to kind of have you guys remember what we did, and kind of as a recap. Also to see, to show you guys what the answers are. Do you guys remember that final exam? What did you think about it? Was it all right? You guys did actually pretty good, for the most part.
It was fun.
I think that your answers were too short for the most. Your answers were not completely detailed enough. But a lot of you had really good answers. Do you think that I should have given you more time?
No.
I didn't give you enough time. Because I could give you maybe a week and a half or something like that on a assignment like that. All right. Anyway, did I have to be really detailed? Isn't it just better to start to get to the point?
I really like the investigation one.
Yeah, but I want you to see. The answers I gave were really kind of just to the point, and I didn't want to write up a detailed answer for my answer key because then I would have to have you guys get all of those points. So I made these points and I just said, well, if they talked about this, 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 and this, then we're good. So we're talking about plates, and we're talking about plate tectonics, and there's 3 ways plates can can interact with each other. You guys remember? They can converge, and usually when they converge, they do one of two things. They either converge, and if it's two continental plates, it's two land plates, right? Then it kind of crashes together, and it can create a mountain, right? It can also create a little valley like this. The Himalayas, the biggest mountains in the world, was actually created from two tectonic plates, the Indian plate and the Asian plate crashing together, and then they're going up like this. If the plates, and this is, this can happen to two continental plates, but it can also happen between two plates that like an oceanic plate and a continental plate, is one can go under the other. And obviously it's going to be the ocean one going underneath the land one, because the ocean is lower than the land, right? And that's called a subducting plate. Cool? And we can know that there's a subducting plate because all of the volcanoes are stacked on one side of the plate boundary. Like the plate boundary is actually between the land and the ocean right here, and all the volcanoes are up on the land. So what's happening is the plate is going underneath the other, and then that friction will heat up the calcium in here, in this plate. And as it's going up, the calcium will leak up to the top, and that will create a volcano over here. So that's the way you know which plate is going on top, because the one that's on top has all the volcanoes on it. Cool? Yeah, they're like pimples. And the when plates are, what else can we look at besides volcanoes? Well, we can look at earthquakes, we can look at seafloor age, we can look at the depth of the seafloor. That's all things that will tell us about how these plates are interacting. Another way that plates can interact is they can converge. They can also diverge if you pull it apart. And that creates new ocean in the middle and old ocean towards the outside, right? And then they can also transform. Which basically means the two plates are right here, like here's California, here's the Pacific plate, and they're going like this. And then that means one's not going on the other under the other, they're just kind of moving like this with each other, and that creates a lot of friction, it creates a lot of earthquakes. There we go. Plates in 10 seconds. That was longer than 10 seconds though, but anyway. Problem number 2. I know, it's alright. Alright. See, here's the thing. A lot of you folks said that you could not see, you should not believe this lady's story because the moon is too dark. But that technically isn't like 100% true. You couldn't see this moon at this particular point in time because that moon wouldn't be in the sky. So yeah, it would be too dark because the moon wouldn't even be there. Right? It's not that it's a sliver of a moon and you can't see it because it's like too small to be able to see it. It's the fact that you won't even be able to see it because the moon will be on the other side of the earth when at 9:42. The only time that you could see it would be if this were more of like a quarter moon and it with the left side shaded in, then you could see that after midnight. That's the earliest you would be able to see that.
That's what I answered.
So if you answered something like that, then that's what I said is the earliest it could possibly rise would be around midnight, and the moon wouldn't even be in the sky at 9:42 p.m. I want you to identify the what this is. This is a waning crescent. The reason why it's waning is because the right side is the dark side, and then the left side is the bright side. I gave you a point for other logical explanations. Like, some of you folks said, well, I shouldn't believe her because look at her drawing of the moon, it's super accurate, and look at the drawing of the guy, it's super junk. Or it's too dark at the time, there's no way that she could see because the forest still has a lot of leaves and stuff like that. But essentially, the idea is the moon is going to be on the opposite side of the earth at that time. So there's no way you could see it. If there was any way you could see it, it would be at around 3 o'clock or 4 o'clock in the morning. And so since that's not the time that the murder happened, booyah. Alright, cool. I like that one. That one was a good question.
Yeah, I like
All right. So for this one, what I wanted you to understand is the S waves and the P waves. And where's my globe? Is it on there? Oh, it's on my bookshelf. Go grab it. I wanted you to understand about S waves and P waves. And I feel like you folks kind of got an understanding of it. Do you guys remember what it is? P waves do what? All right. Come on over here, Shadow. Ready? Come on.
that. Hold it.
Yeah, hold it. You ready? All right. Let's do this here. S waves do this. That's S waves. Right? P waves do this.
This is special.
All right? So P waves crash against each other. S waves move like this. Now, if we're water molecules and we're not actually touching, say that we're water molecules, I'm not touching you, and I go like this. No, you're just going to go like this. So, ready? Ready? I'm going to do a water molecule. Come on, move, Shyler. Move. Move with me. Because I'm moving like an S wave. And you're just probably, dude, you're ridiculous. Right? Right? Does that make sense? But if we're water molecules and I'm not touching you, and then I go, hey, I'm a transverse wave, boom, I'm going to crash into you, you'll still move. So that's why transverse waves make it through liquid, whereas shear waves don't make it through liquid. And the center of the Earth has a juicy core in the middle. So if there was an earthquake happening in Japan, and you were in South America, almost exactly 180 degrees opposite of Japan, here's Japan, South America, here's how the world is actually set up, then an S wave and a P wave would be generated from here, but only about maybe this part of the Earth would see S waves. This part of the Earth would also see P waves, and the complete opposite side would only see P waves, because the S waves wouldn't be able to make it through the juicy core in the middle of the Earth. How many licks does it take to get to that center of that lollipop? I'm sure that it takes a lot. I don't know if you guys can understand the reference. You guys get it? Does this make sense to you? All right. Now, someone who is about 90 degrees, so that I asked you about, well, where is it? What if the person is in Hawaii? Hawaii is right about here. They're about 90 degrees away from Japan. Someone who's 90 degrees would experience both S waves and P waves. However, the P waves would hit the would hit Hawaii first before the S waves. We're not talking about tidal waves. We're actually talking about seismic waves and pressure waves, or primary waves and secondary waves. And the P waves travel way faster than the S waves, so they would hit first. We cool? All right. I apologize. I'm going to go through this as quickly as I can because I want to get through this and I want to start covering astronomy. But I did want you guys to remember what we've been doing last quarter. That way you don't forget these things. So when we take the HSA, because the HSA is on all of this kind of stuff, right? So I want you to really get it. All right. Question number 4. This is another S wave and P wave thing. If there is no P waves to be found on, or if there's no S waves to be found anywhere in the planet, that must mean that the Earth, or that this planet has this giant, super giant liquid core. You know what I mean? The whole thing must be just inside juicy. That's it. We cool with that one? See, some of you folks, this was actually kind of a made up thing. Like I made this up. I didn't put people on Europa. I have never traveled there. I haven't set up any geological sites on Europa, the moon of Jupiter. There is a movie about it where there's a giant octopus at the end. I told you the story, spoiler alert, I'm sorry. But anyway, yeah, there's a movie called the Europa Report. It's kind of a scary movie. Anyway, it's... So some of you actually looked up what the inside of the Europa was, and you told me what that is. You just copied and pasted it from NASA. And so what I kind of wanted you to do is just think about all of these things. And think about, like, what if you only saw S waves and no P waves? Does that make sense? No, and I'm not pointing out anybody, although, Sophia, you kind of pointed out yourself, but I'm just saying that that's why I didn't give you credit for that question, if you did that. All right, this is called spits, and these are called groins. Come on, you guys. Yes, I know. A lot of people people did that, but basically, what happens is what these things are called, or what's happening here is this thing called upshore drift or longshore drift. Let's look it up real quick. Longshore drift. Longshore drift kind of looks like this. I want you to understand the image. What's happening is the ocean waves come in at an angle. And have you noticed that? That, like, you've ever noticed that the ocean waves, they don't come straight into the beach. They kind of come in at an angle. Last time you guys were at the beach, right? So the debris, or like a red cup, would be pushed up at an angle. But then when it's sucked back into the water, it's sucked straight down, and then it's pushed up at an angle again. And then sucked back straight down, and then pushed up at an angle, and then sucked back straight down. So what's going to happen is all the debris or sand or whatever, the beach is going to start kind of drifting up the shore, which is what happened here. This spit was created by longshore drift. How do I get there? See? That's longshore drift. That's why that land is there. Some of you folks answered that there is a volcano that used to be there and that kind of stuff. And I gave you the credit for that because actually, some people say that it is a volcano that did that. And I've seen sources that say that. So that I understand. These little things, these little growings that are coming out of the beach over here. And you see these in Waikiki, right? Do you guys see these in Waikiki? Like there's these little barriers that kind of go out to nowhere, and like the old fisherman goes and fishes off the ends of those things. Yeah, people jump off the ends, but it's just like these walls that kind of go out to nowhere. Well, what's that doing? Well, that's preventing the sand from being washed away, being washed up the beach. Because Waikiki doesn't really have naturally very good sand, so they bring in all the sand at this huge expense. They don't want it to wash away. All right, let me cover problem 6.
How many questions did you have?
There was 9 questions, so we're almost done. All right, this one was created by weathering and erosion. I want you guys to understand the difference between weathering and erosion. A lot of people say that weathering or that erosion is like when things break down. And actually, no, that's called weathering. Erosion is when you take those broken down things and you move them. That's erosion. So there's 2 different kinds of things happening here. All right, and this problem 7, this was the, what do you guys think about this problem?
That was cool. I would want to do that.
Yeah, the swinging one, the pendulum. It was a good problem, and this is actually something that happens, and you guys can actually test out. But if you change the mass of two different objects in a pendulum, it doesn't change the period. That's how long it takes for that thing to go from one side to another. It doesn't change the amplitude. It doesn't really change anything. Well, kind of think of it like this. You figure that the fat guy would have more speed, right? Right?
Yeah.
Because why would the fat guy have more speed?
Because he weighs more.
Because he weighs way more. He has more energy.
I would think he would have more speed, like coming
He has
down
more
and
energy
goes
to right. He has way more energy. Right. I agree. The more massive dude has more energy. Yes, true. But which is it easier to push? If there was a race, okay, and we had Schuyler on a chair and Mr. Dalday on a chair, and you had to push us across the room, who would you rather push? With the little girl versus the fat man. Little girl, fat man, which one would you rather push? A lot of people were saying the fat man just because I would test their strength. You're trying to win this race here. I'll give you extra credit if you win. Right? You would push the little girl, right? Yeah. So it's easier to move something that's lighter. So they would go faster. See, so you get it? So like, I have the advantage since I'm bigger than her, I have more energy. So I would go faster. But she has the advantage because she's easier to push. So she would go faster. And those two effects, and I would go slower because I'm harder to push. Those two effects balance each other out. That's why heavy objects don't really fall faster than light objects. Does that make sense? And what do you mean, Justice? This is so confusing. I just spent, like, you came in for tutoring and I spent 3 hours talking to you about this thing. This specific topic that we're talking about right now. I remember talking to you about it on the last day of school. All right, anyway, I'm not even going to get to my topic. It's so sad. I want to get to this thing. All right. I want you guys to remember the difference between, what are the 3 different types of rocks? Do you guys remember? Cemetery?
Yes.
Sedimentary? Sedimentary, yeah, good.
Igneous.
Igneous and
The morphing one.
metamorphic. Yeah. Yeah, metamorphic. All right. Now, sedimentary is really just a bunch of small little rocks that go like this. And it's like stuck together. It's like a Rice Krispie treat, I kind of think of it. Right? I love Rice Krispie treats. Sedimentary is really just a Rice Krispie treat. And it's kind of a dried out Rice Krispie treat, so it kind of like falls apart and whatnot. Metamorphic is when you like melted the Rice Krispie treat and now it's a little bit more stuck together. You know what I mean? And then igneous rock is when you just completely like charbroiled the Rice Krispie treat. You took the Rice Krispie treat and you threw it inside of your uncle's grill, and it just kind of like is now a burnt piece of toast. Like it is just like this black little piece of ash. That's an igneous rock. We cool?
Some people like burnt toast.
Yeah, okay, whatever. All right, and this one I wanted you to understand the difference between the tides and the moons and all of that kind of stuff. All right, I'm going to get started on my lecture because I don't have a whole lot of time. We're going to talk about the planets. We're going to talk about the universe at this point in time. We've been talking a little bit about astronomy. We spent a lot of time talking about the moon. You guys understand the moon, right? And then we've been spent a lot of time talking about our solar system. So hopefully you understand the solar system as well. The different planets that we have and how they formed and all of that kind of stuff. Now we're going to go beyond the solar system. We're going to start talking about how stars are created, what galaxies are, the different types of galaxies, and all of that kind of stuff. It's going to be really interesting. I have a lot of fun with this stuff. But I'm going to start you off with kind of a distance exercise again. I have on me a quarter that I colored blue. It is the size of her head. See? There we go. It's a quarter. Cool? If this represents what? What do you think this represents?
Moon.
This represents the Earth.
The Earth.
Because the Earth is blue. The blue planet. All right. This would represent what? What do you think? The moon. Okay. Now you've gone through this exercise. You've actually created videos where you've teased people about how much they don't know. So here's my question for you. Earth, here you go. Here, take it. Moon, take it. How far away? How far away should she put these two? Like this close? 2 inches? 3 inches? 17 feet? 17 feet? No. We're shrinking the Earth down not to the size of a basketball, but to the size of a quarter. How far away? 100 yards. Dude, that's too far.
Totally.
All right, what do you think?
What, like in actual size?
Yeah, well, I mean, if we shrunk the Earth down to a quarter and the moon down to a dime, how far? About that far. No. Vernon actually kind of got it. almost. A little bit further than what Vernon's saying. He's saying it's about 1 arm span. It's about 3 feet away. No, that's not 3 feet. How tall are you?
5 feet.
You're right, so you're over 5 feet, so like this would be 5 feet, so 3 feet would be about 1 of your arm's length. Are we cool? So, you guys got it? A quarter, the moon is a dime, they're about 3 feet away. Is that interesting? Ooh. No, that's not interesting. You had us do a thing. Alright, check this out. It took America, 10 years to get to the moon. The thing is like 3 feet away. It took us 10 years to get to the moon. Isn't that crazy? Only 9 sets of people have ever been on the moon. You want to know something crazy? In the last 50 years, 50 years, we haven't been further than the ridges on this quarter. Every astronaut that's gone into space hasn't been further than the ridges on this quarter. Because we traveled to the moon 50 years ago, and after that we didn't go further than that. All right, now I got my Earth. She rubbed off the red or the blue that I covered on that.
You're welcome.
What do you think this is? This isn't the sun.
Mars.
It's Mars.
Oh, it's a sun.
It's a nickel. That's Mars. All right. So this is the size of the Earth. This would be about the size of Mars. How far? I'm gonna hold the Earth right next to the camera. Earth's right next to the camera. Mars is where? 6 feet? 10 feet?
Are you asking me?
No, well, I'm asking the class, I'm asking you. She said 7 feet, 7 or 10 feet. All right, let's go. Let's do this. Oh, there's my Earth. Oh,
Oh, you just dropped it.
there's an earthquake.
There.
All right, here, Charlie, start going. All right, you guys see Skylar? Can you see her? All right, is that far enough? Is that far enough for her, or should she keep walking? They say it's too far. Stop. No, they said keep walking, actually. Keep going back. Keep going back. What do you guys think? Stop or is she good? No, they said keep walking. Keep going. Okay, alright. So it seems like half of you are saying that's good, half of you guys are saying it's too far, and a few of you guys are saying that's that went too far, and a few of you are saying go further. Alright, where are you at? You're at the end? Okay, come on back. Okay, let me show you. Let me show you how far. You went about, I think, about 40 feet. That's how far you were. Would you like to know how far it actually is?
Got my workout for today.
Okay, so she walked from here, this part of that building, to here. See, there's the YWCA building. This is the room I'm in right here at that corner. And here's the other corner of the room. So you walked about 40 feet. You would have needed to go downstairs, across the street, across this long parking lot, to Iolani Palace, to the other side of Iolani Palace.
I'm glad I didn't do that.
That is how far. If the Earth were a quarter and the moon or the Mars were a nickel, they would be placed 500 feet apart. Come on. That does not blow your mind? That's got to blow your mind a little bit. Lucas is like, I kind of expected that because it blows my mind. All right, you want to know what really blows my mind? I mean, think about this. Have any of you ever shot archery?
Yes, me.
You've shot archery?
I won. I wanted.
We have a professional archer right here. Okay? Alright. You almost hit a person. That would be considered a very good archer. Actually, that could be considered a good archer or not a very good archer, depending on what your actual target was. Okay, so you've shot archery. Have you ever shot like rifles or like BB guns or something like that? All right. If I took this nickel and I placed it on the other side of Iolani Palace, and you had a gun, or you had a bow and arrow that could shoot that far. That's the first obstacle we'd have to get over. But you had a bow and arrow that could shoot that far. Could you shoot the nose hair on this guy's face? And who is this guy? This is Jefferson? Is this Jefferson? I don't know. Nickel.
It's the man.
Could you shoot the nose hair on this guy's face from 500 feet away? That's what we did 3 times already. No, we've shot Mars.
What?
We shot rovers at Mars, land rovers. And in order to hit that, it would be like hitting a nickel 500 feet away. That's like across the street, across the park, across the parking lot, on the other side of a giant building with a slingshot. That is how hard that task is. So it's not like we send these people to Mars. You know what I mean? That's like, oh yeah, let's just do it. You want to know how hard it would be to send people to Mars? In fact, you want to know who could send people to Mars? That's a problem for you to figure out. Because you're about the age where you guys will be sending people to Mars. And so scientists that are your age right now are going to grow up and figure out how to do that. Because my generation, have gotten robots to Mars. Your generation is going to have to get people to Mars. All right? I've done my part. I'm teaching you guys your physics that you need to get to there. So anyway. All right. So what else are we talking about? Okay. All right. So we're going to talk about how planets are formed. Let's go to here. Wait, my computer froze a little bit, huh? Oh, there we go. There. Got it. All right. How is a solar system formed? Well, here's how a solar system is formed. First thing that we have to kind of talk about is a solar system is kind of circular or elliptical, right, in nature, and it's kind of flat, right? The planets don't orbit; they all kind of orbit like on a disk, right? Then some don't go like this, and some don't go like this, and then like the planets just kind of going all over the place. They're all kind of on this imaginary plate, so they're all kind of on the same like disk. Is that cool with you guys? Because the fact that we know that they're on this disk kind of helps us understand how these planets form. Well, what happens is there's these giant clouds that we call nebulas. Now, a nebula is, and this is really just a hypothesis. We don't really know. In fact, to be honest with you, as a scientist, a lot of you folks are. Some people are even saying like, "Well, I'm, like I don't believe in God. I believe in science." And some people are saying, "I don't believe in science. I believe in God." And you know what? My answer to that is, what I'm teaching you now is really a theory. Okay? There's a lot of evidence to support this theory, but I'm not telling you that, like all of these things are wrong or right or whatever. This is just a theory because in order for it to be a fact, someone had to be there to see it. No one was there to see this stuff. That's the bottom line. You know what I mean? no human was there to actually see it and record it. So we don't know. This is all speculation. So all I'm doing is I'm showing you what we think. So this is one, we actually call this the solar nebula hypothesis. One hypothesis for solar systems being created is these nebulas. And these nebulas is a bunch of hydrogen and helium. And these nebulas are created, here's a nebula, which kind of looks like an eye, which I think is really cool. Is these huge things of hydrogen and helium, and it's like a bunch of dust, and it starts to kind of collapse on each other. And as it collapses, like it will get so heavy in the middle that what's going to happen is you're going to have what we call nuclear fusion. Now here's what nuclear fusion is, all right? Because this can get a little bit confusing. Have you guys ever, do you guys understand that, have you guys seen the periodic table? Yes, you've seen it, right? Do you guys know, all right, I'm going to start teaching a little bit of chemistry, and then we're actually done. In fact, actually, what I'm going to start to do is I'm going to send out an email. I'm wondering, do you guys have a class before this? What classes before this? You have English. When does that end? It ends at 9?
Really early. Yeah. I don't think them till like 10.
Okay. Do you think that I could move up my lecture to like from 11:45 to do it at 11 o'clock?
Yeah.
Would that mess you guys up?
No.
Because what I want to do is I want to make it, oh wait, you have math? Okay, never mind. You have animation. All right, well, I guess I can keep it. Because I have a meeting actually, next week I'm going to start having a meeting at exactly 12:30, so I won't be able to go overtime anymore, which is kind of a bad deal for me. So maybe what I'll do is I'll optionally start the class a little bit earlier and then, do that. But anyway, here's what's going on, all right? In the periodic table, you have one proton. Do you guys know about what's inside of an atom? Do you guys know?
I am.
You have a proton. There's a nucleus. The nucleus is the middle part, right? And there's an electron, and the electron's kind of just going around like this, right? You guys understand an atom? There's a nucleus, and inside the nucleus there's two things. There are protons and there are, his first name is Jimmy, his last name is?
Jimmy Neutron.
Neutrons. There we go.
I'm a genius.
All right. So inside the middle of an atom you have protons and neutrons, and on the outside going like this are the electrons. They're just kind of like hanging out around the outside. Cool? What is the charge on the electron? Do you guys know that? The electrons they're negatively charged. Got it? So electrons are negative. Protons, on the other hand, since it starts with a P, they must be positive. There we go. Protons are positive. Electrons are negative. What are neutrons?
Neutral.
Ah, Schauder says neutrons are neutral. What does that mean? No, you're totally right.
I'm totally right.
Yeah.
I'm just like,
No. Neutrons are like, are you positive? No. Are you negative? No. They're in the middle. They're meh.
me.
Right? So it's like they're not positive, they're not negative, they're just zero. They're nothing. Okay? You guys got it? Are we got it so far? Are we good so far? So when you look at a periodic table, I'm going to teach you chemistry now. When we look at a periodic table, do you see that one above the hydrogen right there? This one right here. That one right there. One. You see that? That means there is one proton in there. The helium. How many protons are in the helium? two helium, 2 protons for helium. The lithium, how many protons does it have? Exactly. How many protons does mercury have?
Oh, that's
80.
80.
How many protons does lead have?
82.
82.
Do one of the teal ones. This is pretty.
How many protons does iodine have? 53. So an element is described by the number of protons that it has. And the numbers on top tells you how many protons there are. This is chemistry. You're actually going to learn this when you folks are juniors in high school. But I'm teaching it to you now because I'm a nice guy. Usually, there are the same number of neutrons as there are protons in an atom. So hydrogen has 1 proton, so there's usually the same, usually what? 1 neutron to go along with that 1 proton. Does that make sense? An element can have more than 1 neutron, but it can have one, like you can have an unbalanced amount of neutrons because neutrons don't add charge. So if there's only 1 proton and you have 2 neutrons, that's called an isotope of hydrogen. It's like hydrogen, just a little bit heavier. It's the fat hydrogen. We really literally call it the heavy hydrogen.
It's so judgmental.
I know. I know. Anyway, if a proton only has a proton and no neutron, it's like the skinny hydrogen. Right? So anyway, those are still hydrogens because if I have 2 neutrons and 1 proton, that is called a hydrogen isotope. But if I had 2 protons, well, what do I have now?
Fat.
No. I have helium.
Oh, you have helium.
Because if I change the number of protons, that changes the element completely. If I change the number of neutrons, that just adds mass to it, but it doesn't change the element. You guys get that? So the protons is what defines the element. That is why the number on top is called the atomic number, and that actually tells you how many protons you're dealing with. It doesn't tell you how many neutrons you're dealing with, but it tells you how many protons. Because if I change the number of protons, it changes the element completely. We cool? But if I change the number of neutrons, that would just make a heavier or lighter version of that element. It will still be the same element. Like if I had 23 protons, I would have vanadium. If I add in some neutrons in there, it would just make a heavier vanadium, but it would still be vanadium. Does that make sense? All right. I actually have to finish now because I'm way over time. I'm sorry. I didn't get through all of my lecture. I didn't get through almost any of my lecture. But start having fun. Have at it, folks. You have your assignments. They're posted already, and I will talk to you folks later. I hope your mind was blown because I like doing that. All right. Talk to you folks later. Okay, by D is due. It's due on the 10th. Yeah, something is due on the 10th, I believe.
Yeah, it's that one that you assigned.
Yeah, it's just a reading. You just got to read it, and then it's due. All right, cool. Talk to you folks later. Oh, and by the way, I'm actually kind of backing off on the amount of assignments I'm giving you. I'm going to limit the amount of assignments I give you to about 2 or 3 a week. So usually I give like 3 or 4 or even 5 assignments. I'm giving you like only 2 or 3. Because I noticed a lot of you folks said, back off on the number of assignments you give us. So I'm going to try doing that. That means you promise to turn them in, though. All right. Talk to you later. Goodbye. All right.